Hello everyone, this is Niharika. My topic is IIR parallel form structures. Here, IIR means infinite impulse response. It is used in telecommunication, clock recovery in data communication, signal monitoring, etc. IIR is further divided into cascaded and parallel direct form. So let's get into the topic. Parallel realization of IIR filters. The transfer function h of z can be written as a sum of transfer functions h1 of z, h2 of z, so on hk of z obtained by the partial fraction expansion, where y of z by x of z is given as h of z, which is equals to h1 of z plus h2 of z plus so on till hk of z. Y of z is equals to h of z into x of z. Multiplying all the h1 of z, h2 of z with x of z, we obtain this equation and is shown in the diagram shown below. The outputs y1 of n, y2 of n, so on yk of n are not dependent on each other. They are not coupled as in case of cascaded structure. Based on whether hz of z or h of z is the beginning point for the partial fractions, we have parallel forms 1 and 2. Both of these methods are shown below. Parallel form IIR digital filter structures. The two basic parallel realizations of a third order IIR transfer functions are shown below. The first figure shows parallel form 1 and the second figure shows parallel form 2. Let's get into parallel form 1. This corresponds to expanding h of z by z in spite of h of z into partial fractions. This structure is obtained when the h of z are all selected to be of the form, that is hi of z equals to b0 plus b1 z inverse by 1 plus a1 z inverse plus a2 z power minus 2. On expanding, we get z into b0 z plus b1 by z square plus a1 z plus a2. Here, the quadratic terms are used for every pair of complex conjugate poles such that the coefficients of corresponding hi of z will be real. Every hi of z is then realized as a dfi or df2. The special cases of hi of z are as follows. hi of z equals to b0 or hi of z equals to b0 by 1 plus a1 z inverse. Let's look at an example. A partial fraction expansion of h of z equals to the given one in z inverse yields. On separating it into partial fractions, we get h of z equals to minus 0.1 plus 0.6 by 1 minus 0.4 z inverse plus so on. The corresponding parallel form 1 realization is shown below. Coming to the parallel form 2, it corresponds to expanding h of z directly into partial fractions. This structure is obtained when hi of z are all selected to be of the form b1 z inverse plus b2 z power minus 2 by 1 plus a1 z inverse plus a2 z power minus 2. Likewise, a partial fraction expansion of h of z in z yields h of z equals to 0.24 z inverse by 1 minus 0.4 z inverse plus so on. The corresponding diagram, which is below, is of parallel form 2. Realization using MATLAB. Parallel forms 1 and 2 can be developed using the functions residues and residue respectively. Thank you.